should be the same. So this tension and this tension have to be the same. So the tension that one box is exerting on the other is equal to the other tension. Okay? So every time that you have two objects with the cord, you will have on each side tension. And those tensions have to be the same. This is an application of the Newton's third law. Good. Knowing that the three laws of motion, we are now in good position to start solving problems with the Newton laws. Let's start with the basic. So summarizing the laws. Number one, the Newton's first law we will apply it when the object is moving or is at rest or is moving at constant velocity. Number two, the Newton's second law is equal to mass time acceleration. We can use this along x and along y when the object is accelerating. And the third law, whenever we have cord or anything, two forces acting on each other, the forces will be the same. Force 1 on 2 is equal to force 2 on 1 negative. And the magnitude are the same. Okay, these are the Newton's three laws. Application. Let's start finding. First problem. Number one, problem is very simple. Let's say that I give the mass and the acceleration. I ask for the net force. What do? You just multiply mass times acceleration and you look for the net force. Very simple. Sometimes they are not so explicit. And sometimes they give the position of the particle is 3t squared. Find, and the mass of the object is 2 kilograms. Find the net force acting on the object. How can you find it? Yes.
Find the second derivative.
I get the second derivative of the position. What do you get when you get the second derivative of the position? The acceleration. We have the acceleration. Once we have the acceleration, you multiply by the mass, you get the net force. So, very simple problem. Since I gave the position, we get the first derivative, that's the velocity. So this will be the derivative of this position, which is 60, right? 60, this is the velocity at any time, right? And then the second derivative, which is x second derivative, which is the derivative of v, which is the acceleration, is just 6 meters per second squared, which is the second derivative. Any question on that? Now we can get the net force. What will be the net force? 6 times 2, 12, what?
Kilograms.
5 meters per second squared, but with Newton. 12 Newton. This is the net force on the object. Very simple problem. I give the mass and I give the gravity. How do you find the weight? You multiply the mass times the acceleration due to gravity, you find the weight. Very simple. But these are not calculus, physics with calculus type of question. This can be one multiple choice. Okay, now what are the typical problems where we have to solve problems more complex? So problems where I give a certain situation and I will ask to find either a force or the acceleration. For example, let's start applying the Newton's first law. Let's say that we have a cord with, like this, and here we have a how do you call it? Yes.
Traffic.
Traffic light, right. Smart. Traffic light, here. So we have, I give angle 1, 30 degree, and I give this, let's say, 45 degree. The question, find the tension 1 and tension 2 on the core. The mass is given, the mass of this, which is, let's say, 10 kilograms. This is the problem. So, I give the traffic light, which is hanging at 2 different angles. Can be the same angle. Okay, I gave different angles, just 2, but can be the same angle. And I can ask, find what, and I give the mass, find a particular force. This is what we call a more complex problem than simple to give the mass, the acceleration, and find the net force. This is not the way that will be here. So I give a problem, and like in the study guide, can you see the study guide? The first problem here. This is similar to this one. Or the second one also is similar to this one, correct? In the study guide. All right, let's do this. The first step for every complex problem, what is I call complex problem, applying the Newton laws or application of the Newton laws. When you have a problem and certain things are given, like the forces or mass of the object, and I will ask for a particular force, or for the angle, or for the acceleration. I can give certain things, but you need to find the rest. Now, usually you don't have velocity, and velocity initial, final, because you could use the big 3, or you could use the derivative of the position, but I didn't give anything. This is a rest. I am asking for tension 1 and tension 2, individual forces. You need to apply the Newton laws. Which one? Always. The first or the second. The third is a constant. Always you have to choose between the first and the second. How do you decide if you will use the first or the second? If the object is moving, not moving, or moving at constant velocity, or is accelerating. In this case, there is no wind, no hurricane here in Miami. We are living peacefully, right? What Newton law you will apply? First, the traffic light is not moving. So, Newton first law. The Newton first law, in order to find the tension 1 and tension 2, Newton first law, what is the algorithm? In physics, always there is a method and there is an algorithm. What is the algorithm? And always you have to apply it. In order to get anything with the Newton laws, this is the algorithm. You use it or not. My duty is to teach. You can use it or not. If you don't use it, it will be very painful to solve a problem. If you use it strictly the way that I will teach, you will get everything done quickly and efficiently. First step, set up the problem. Set up means get the given and unknowns. Because we have that, for the most part, we don't need to set up here. It's pretty much set it up. But if you want to set up, you say theta 1, 30, theta 2, 45 degrees, mass 10 kilograms. I am looking for T1 and T2. This is much organized than this. You can see what you have and what you don't have. This is what we call setup. This is the first step. Second step, draw the row diagram of the situation if it's not given. Here, we don't pay attention to the details. We just draw in which direction are the forces acting on the particular situation on the system. What are the forces acting on the system? What is the object under study here? If I am asking for tension 1 and tension 2 on the traffic light, what is the object under study? which is called system, the traffic light. So we care about the forces acting on the traffic light. We don't care about the forces acting on the ceiling, because that's not concern to us now. Got it? Can be the same, but I don't care. I care about the forces acting on the traffic light, which is the system, object and the static. So this is tension 1, or tension whatever I call, tension 1, tension 2, and what else is acting on the traffic light? The weight, F, G. These are the three forces acting. Any question on drawing the row diagram and step number 2? Step number 3. Draw the what we call free or force, either free or force, body diagram, which we call FBD. Free body diagram or force body diagram, it doesn't matter. That is the FBD. What is the difference between the FBD and the row diagram? That here you will see clearly what forces are on the y-axis and what forces are on the x-axis. This will be what we call FBD. We don't care about the details. We don't care about how beautiful is the traffic light. We care that here we have a coordinate system. If the object is not moving, we will turn, or we will set the positive direction like we do in math. Positive to the right, positive upward. If it's moving, the direction of motion will be our positive direction. Very important. But in this case, it's not moving, so I will say that my positive direction is this way and this way. I only use one arrow to set that that is the positive direction. This is confusing and waste of time. This is my negative. I don't have to write, draw an arrow there. Only on the positive direction. Then, at the origin, you put the object. This is the traffic light. And now I draw the forces that I have here. Tension 1, you don't have to care too much about the direction. You just care. Tension 1. Tension 2. Weight. You don't have to put this on the axis. You can put it off the axis for better visualization. The purpose of the free body diagram is that you want to visualize clearly the situation. So you can move the forces off, but you know that they are pointing in the right direction.